Let's take a look at a few examples through the class that you see on your screen named Scope, Scope 1. In this class we have three methods, and we will be revealing the method bodies in a little bit, and one variable. The instance variable you see declared on line 3, where can we use it? What is the scope of that variable? Remember the basic rule we mentioned about enclosing blocks. We can use it from the point where it is declared, from line 3, and until the end of the enclosing block, which is the block, the end of the class. Now remember, an instance variable cannot be accessed directly from non-instance methods. So although methods 1 and 2 can directly access the instance variable x, because they are also instance methods, they are not static, the static method main cannot directly access it. We need to first create an object of type scope1 and then be able to access the variable through that object. We have talked about instance, both variables and methods, and static variable and methods before. So this x variable is visible. We can use it in method 1 and also in method 2. Now see what we have done here. We have provided a parameter to method 1 and given exactly the same type and name as a field in that class. Is this the first time you see it? Definitely not. We have done it multiple times. In constructors, what have we done in constructors? We have a parameter, say x, and then inside the body of the constructor we say this.x, meaning the field variable, becomes equal to x, meaning the value of the parameter. So declaring x here is perfectly legal. We say that the declaration of x here hides the field x. In other words, whenever we are writing x inside the method body, we are referring to the parameter, not the field. So the parameter is hiding the field. If we want to refer to the instance variable, as I mentioned before, we need to do that through this.x. Now, if we want to go and declare again int x inside the method, as you see the note, and also you will see the mistake that IntelliJ IDEA will underline, which says variable x is already defined in the scope. So we cannot redefine x again inside the method, which has already a parameter called x. You can think of it as if we have already defined y, and then on the next line we go and we try again to declare y. So this is a compile time error. We cannot do that. In the same way, we cannot declare x again, because there is a parameter named x. You can, again, for purposes of scope, you can think of parameters as local variables that are declared at the very first line inside the method. That's why it is as if we are declaring x twice. Parameters are like local variables in that sense. So it is not possible to have another local variable named x. It is possible to have a parameter. Great, so this is how the first method 1, looks like. Let's see what we go and do in method 2. Method 2 does not have any parameters as one head that are called x. So defining a local variable called x of type int is perfectly fine. In the same way, it is just hiding the field x. In the same way, if we want to, wherever we write x inside the method body, it will mean the local variable x. If we want to refer to the instance variable x, to the field x, we need to do that through this. We need to say this.x, and I will write the same thing, becomes equal to x. Not very meaningful, but definitely legal. Not very meaningful in this context. So again, the field member of the class is hidden, but we can still access it, and it has to be through this. Now, if we try to declare x inside a while loop, for example, that is illegal. Why? Because the local variable, what is the scope of the local variable x? The scope is until the end of the enclosing block, so it is until the end of the method. When we try to declare another local variable x, even if it is inside another block, we cannot do that. Why? Because in lines 15 to 17, the local variable x defined in 11 is still visible. X is still in scope. We cannot go and define one more x variable there, even if it is for a subset of the scope of the other variable. So this is not legal. We cannot have a second local variable within the same scope, even if it has a shorter scope. This is how method 2 looks like. Let's go and take a look at the main method. Inside the main method we have several different blocks of code, which are again completely legal. We have one block, a second block. In the first one, x takes the value 12. In the second one, again, it is legal to define x again as a variable and give it a different value even, or even the same, it doesn't really matter. The scope of the first x variable is until the end of the enclosing block, so until line 23. The scope of the second one is from line 26 to line 27, until the end of the enclosing block. Let's take a look at the for loops now. In the for loop, first for loop, we are declaring an int variable I. What is the scope of that variable? The header of the loop and the body. So I is visible on line 30. However, on line 33, that I is out of scope. Why? Because we have declared it within the for loop, so it only lives within the for loop. Same thing here. This is a different I variable. So if we try to run, for example, this very simple program, what will the two loops do? The first one will print the values of I. The values of I will go from 0 until 9. The second one will again start from 0 and go again until 9. It will not start from the value that the previous loop stopped. And the result is here. We see all the values from 0 until 9, and then again all the values from 0 until 9. And again, after the second loop is also over, I is out of scope. It means we no longer know for what we're talking about when we say I. Why? Because the scope of I is again within the loop limits. Just a final note for which reason we have created this second scope class. The main difference from the scope 1 class that you just saw is that we also have a string name field here. So the constructor in scope 2 has also a second parameter. Now, the difference, however, is that the second parameter does not have exactly the same name as the field. In other words, the name variable is not hiding the name variable because they don't have the same name. So we can initialize it by just using the identifiers of the variables, just using the names, without having to use this dot field name becomes equal to parameter name. Using the this dot x becomes equal to x is a very common style. You should know it, you should use it if you like it, but it is not the only way. We could have the variable have a completely different name, and so that the two variables are not at odds. The parameter and the instance variable. You see how the constructor will be used in the main, nothing special, and again, you can see the same kind of use of variables inside the doIt method. A local variable having same name as an instance variable. This.x will be the way we access the field, x will be the way that we plainly access the local variable.